So for this reassessment, we're going to be looking at collisions. We have a problem which states a krypton atom with a mass of 83.9 moving with a velocity of 0.80 kilometers per second to the right, and a water molecule with a mass of 18.0 moving with a velocity of 0.40 kilometers per second to the left collide head-on. The water molecule has a velocity of 0.60 kilometers per second to the right after the collision. The symbol basically U just stands for the atomic unit. And in the equation, we know both of our initial velocities because we know the velocity of our krypton atom as 0.80 kilometers per second, and our velocity of our water molecule is 0.40 kilometers per second. So therefore, we can solve for the second final velocity by applying the momentum conservation equation. So in the equation, we're going to let subscript 1 refer to our krypton atom, and then subscript 2 is going to refer to our water molecule. And from our equation, we know that our momentum of our krypton atom plus our momentum of our water molecule is equal to our initial momentum of our water molecule and our initial momentum of our krypton atom. So therefore, we substitute momentum into our equation, and basically momentum is basically saying our mass times our velocity. So therefore, we get something that looks like this, which is m1 v1 of F plus m2 v2 of F equals m1 v1 of our initial plus m2 v2 of our initial. So worked out, we can divide our mass of our krypton atom plus divided by the mass of our water molecule. And if we go back, we know that the mass of our krypton atom was 83.9 and our mass of our water molecule was 18.0. So we can go into our equation and divide our mass of our krypton divided by our mass of our water molecule, and we get 4.661, which we are going to substitute in our equation for m1 v1 of F plus m2 v2 of F equals m1 v1 of our initial plus m2 v2 of our initial. So if we supplement that in, we see that our m2's cancel out, and we get left with our velocity of our krypton final, which equals 4.661 of our krypton initial plus our velocity of our initial atom minus our velocity of our final momentum divided by, of course, our mass of our total our total mass of our equation. So we get down below 4.661 times 80 kilometers per second, which was our velocity of our krypton atom, plus a negative 0.40 kilometers per second for our water molecule. And if we go back, the reason why it is negative is because they're colliding, so therefore that water molecule is going in the negative x direction, so therefore it's going to make that negative. And then we're also going to subtract that from our total velocity after the collision, which was 0.60 kilometers per second. And if we divide that by total mass, we get 0.59 kilometers per second for the final velocity of the krypton after the collision. So therefore, that is how we set our equations up and how we solve for the velocity of the krypton after the collision. So pretty worked out problem that describes how to implement our momentum conservation equation and how to solve for collisions.